In this video, I'll show you how to produce real-time audio with Windows native multimedia library in C. Note that I'm compiling this code with GCC. To compile, we need to link to WinMM. The code and build script can be downloaded from the text version of this tutorial, linked below. To use WinMM, we include mmsystem.h. First, we need to define our sound wave format with the waveformat.ex structure. PCM stands for pulse code modulation. It means that each sample represents how far the speaker should be extended at each step. It's the simplest, most direct, and most common sound format. For now, I'm using one sound channel. More channels would generally represent more speakers, so to play different sound data from two different speakers, you'd use two channels. That would be standard stereo sound. The sample rate is how often we'll update the speaker position per second. 44,100 Hz is the standard sampling rate for CD audio. We're using 16 bits per sample, which is also standard. CB size lets us tell the structure how much extra space we're using for extended format information. We're using the standard PCM format, so we don't need any. We calculate n block align, which is how many bytes each sample requires, and the average bytes per second has a self-explanatory name. We call the waveout open function, passing it a pointer to our waveout handle to fill. The second argument is the ID of the sound device we want to use. WaveMapper selects the default device. We pass our wave format, a pointer to our waveout callback function, and a flag to tell it that we're using a callback function. Using a callback function means that whenever something happens on the waveout device, our program will be interrupted by a call to the specified function to handle whatever happened, such as finishing playing a sound data chunk. There are three other options, but a callback function is simple and effective. In a performance-intensive program, a separate thread can be used to handle audio without interrupting the program. Setting the volume here sets the internal wave device volume. We want our audio to be sent along to the speaker driver without decreasing. Then the user can adjust their speaker volume either through Windows audio controls or with their physical speaker controls. We have to send audio to the wave device in chunks, so we create two chunks holding 2,000 samples each. I'm using this wave position, wave step code to generate samples of a sine wave which will be continuous across the chunks. We use these wave headers to hold a pointer to the chunk data and length of the chunk in bytes. Since each sample is 2 bytes, we multiply the chunk size by 2. We give the header to WinMM to be prepared for writing to the wave device, then pass the header to waveout_write. The first sound data sent is immediately played. We loop through the same code again, setting up and sending the second sound chunk. Whenever a sound chunk is finished playing, WinMM will call our callback function with a WOM done event. In that event, we fill the completed chunk with new sound data and write it back to the wave device. This will continuously add a new chunk to the wave device whenever one finishes. In our main program loop, we use _getche to retrieve any button presses in the console window, and respond to the up and down arrow keys by adjusting the wave frequency. Escape causes the program to quit. This adjustable sine wave is just a simple way to demonstrate that the sound is working and to test the latency. In my opinion, the latency is low enough that it feels as if the sound changes immediately upon pressing the arrow key with these settings. That's how to play real-time audio with Windows native multimedia library in C. In my next tutorials, I'll show you how to load sound files, images, and do precise timing in C. Cheers!